morning, everyone. Welcome to this session. My name is Timo Kistner. I'm leading the manufacturing vertical for NVIDIA in the EMEA region. NVIDIA is all about accelerated compute, right? How can we accelerate AI workloads? How can we accelerate workloads around the industrial metaverse? And that's what I would like to guide you through. Industrial metaverse, what is it? What kind of technologies are we leveraging there? Why do we do that actually today and not a couple of years ago? So let's look into what do we actually mean when we talk about the industrial metaverse. And you will hear me talking about industrial metaverse all the time, right? This is important, right? It's not about the metaverse, what you've seen in the consumer space, right? We're talking about industrialized metaverse, meaning whenever I say industrial metaverse, you think physics-based. Everything that you see here is a physics-based visualization. It's a physics-based simulation, right? It's not about just visualizing something and it's nice to see. No, it's about representing the actual reality as close to reality as possible, right? And of course, the metaverse is all around combining technologies, right? It's not XR. We hear sometimes, well, metaverse, yeah, so where is the XR part of it? Yeah, well, yes, XR is one part of the industrial metaverse, but it's about combining technologies like machine data, IoT data, right? It's about combining robotics. It's around AI, generative AI. How can we leverage all of that? This is what we talk about when we mean, or when we talk about the industrial metaverse. Now, we see companies around the globe racing to digitalize further all of their operations along the product life cycle, along their value chain, right? Why is that? You all have heard about the labor shortage, right? How do I get enough people to work in my factory? How can I break up data silos in the engineering side, in the R&D space, right? That's where the industrial metaverse can help actually gain additional efficiency, can tap into different data tools, different data sources, right? Combine all of these different sources to really accelerate the workloads behind. Leveraging AI to actually overcome that labor shortage and really go to the next level and still run your factories on the highest level of operational efficiency. Now, there are a couple of technological enablers when it comes to the industrial metaverse, right? And this is about open standards, super important for us. I'll walk you through that. What does that mean when we talk about those standards? How can we leverage new technologies, new standards to actually tap into all those various data silos that we have out there? It's around leveraging robotics and generative AI, right? Everything what's currently going on around AI and moving forward with Gen AI, how can we leverage that to become more efficient, to become more cost effective? And of course, it's around accelerated compute. How can we leverage the latest technology with our partner AWS, for example, in the cloud, right? So let's look into the topic of the open standards, right? And how can we use an open standard to tap into all those various tools that are being used along the product lifecycle, and how can we use that to become more efficient? Universal scene description. This is, from our perspective, the standard when it comes to describing 3D scenes and 3D worlds. Why is that? What is USD actually doing? USD is a standard that really helps to bring all kind of data sources to a unified level, right? I was talking about the different tool sets out there in engineering, in the R&D space, right? All of them working on different formats. And with USD, we help our customers to really bring all those different data sources into one unified format. And what you see here on the left side and on the right side, this layered stack of that robot and that assembly line. This is how you should think about the technology behind USD, right? All those different layers, they are coming out of different tools, out of different engineering tools, tapping into those data sources. And with moving that data into USD and having this layered approach, you ultimately get to this visualization, right? A full fidelity visualization, combining all kind of third-party tools, bringing that to a completely new level of visualization. Now, be aware or be mindful with when you talk about full fidelity visualization. Yes, the robot, the production line here, they are photorealistic. Yes, that's one part of full fidelity visualization. But of course, there is more behind that. Like, we're not talking only about the actual visual that you can see, but we're talking about metadata. So the robot, this is not just the hull of that robot. There is metadata behind, the path planning of that robot, the machine data, the IoT data from that robot. All of that is what you can combine, right? So USD is not just a format helping with 3D scenes and 3D worlds. It can basically transport every kind of data, right? And that's what makes it so universally applicable for these applications. Important to know, we, together with other partners that you see on that slide, Pixar, Adobe, Apple, Autodesk, we founded what we call the Alliance for OpenUSD. We founded that last year, and since then, we had quite a lot of companies joining that alliance, driving USD to the next level, driving USD into all the different industries, like looking, for example, at Ansys, Hexagon, Siemens leading one of the working groups around unified modeling that's really needed in that industrial space, right? So we're very happy to see all these companies joining Alliance for OpenUSD, and of course looking forward to drive this standard really to what we would see sort of the 3D standard comparable to HTML, what we've seen before, right? For us, USD is really the standard when it comes to the industrial metaverse. Now let's take one step further and talk about robotics, generative AI, how can we leverage all those technologies, and what does it mean for us, especially Gen AI, when it comes to those 3D workflows. The next wave of AI is going to be what we talk about in terms of physical AI, meaning that it's not just an AI which sort of maps something and is able to help you understand what's going on, but it actually will be the combination of the physical asset, right, and really help you optimize that physical asset. Combine vision AI, combining the insights, for example, from the factory, and then put this back and feed that back into the actual operation of those assets. So from our perspective, the industrial metaverse will become a very important tool to actually not only map out your environment, right? But this is going to be the environment where you will train actually your AI models in, right? And this is going to be the environment that actually going to close the loop between the actual virtual asset and the reality and all the physical objects and assets on the shop floor, right? And a couple of examples here, right? For example, training and testing AI and robotics, automated guided vehicles, right? In that case, it's an example from autonomous driving, but you can transfer that right away into the industrial shop floor, right? When you talk about autonomous mobile robots, for example, right? Using AI to create different instances of your assets out there to come up with a new perspective of your environment and help you, again, optimize. It's all around effectiveness. It's all around operational efficiency. Generative AI, I assume every one of you has used Gen AI, at least in private, right? If not already in the enterprise environment. We're talking about the iPhone moment of AI, right? It's all about combining different data sources, be it text, be it speech, be it video feeds, be it images, tapping into all those different data sources, combining that and creating new output with the help of generative AI. And that's, of course, an important lever also to help us with 3D workflows, right? How do we actually create 3D scenes and assets, right? This is where generative AI can help you. How do we actually create diversity in 3D assets? Domain randomization, right? I might not want to have only one scene, but I might want to try out thousands of different scenes. And this is exactly where generative AI can help create all those scenes without the manual effort that we had before we could tap into all those data sources. Combine them with generative AI. And of course, it's about natural language interaction. How do we combine that? How do we make it as easy as possible for the user to interact with those tools? Right, and a couple of examples here, synthetic data generation, I mentioned that before, domain randomization. Right? Now this is again out of the autonomous driving environment. How do we create versions of those assets automatically? Right? You don't want to do that by hand. Right? This would take hours. This would take way too long. There are not enough resources out there to do all of this manually. Right? But we can automate that with generative AI, with synthetic data, and then have all those various scenarios in our industrial environment, in our virtual industrial environment, to try out different scenarios to optimize, like how is our asset interacting, how is our AI model actually interacting with the virtual environment. And that's actually a super important part, right? When we talk about physical AI and how do we combine the AI models with the virtual world and the real world, right? Think about it. We talked about labor shortage before. We talked about the shortage of engineers that are capable of actually doing all that work that you saw here in those 3D workflows. Now, we need to think about an environment that actually helps you try out all your AI models. Not only train the AI in that virtual environment, but really try it out, test it out, right? If you train a robot, if you train robotics perception in the industrial metaverse, well, you want to train it to an extent that once you deploy your new robotics perception model to that actual robot, you want to make sure that it runs perfectly. And that's exactly what the industrial metaverse is bringing to the table, right? That helps you really in that virtual environment to test out all the models, test out all the functionality, right? And that's why it's so important that it's also photorealistic, right? We haven't talked about that. Photorealistic environment. Well, if you want to train your sensors, you want to make sure that that sensor in your virtual world actually sees what he would also see in the real world, right? That's why we make this photorealistic. So we're not only talking about photorealistic, but we're even going one step further, right? We're leveraging ray tracing, simulating rays of light, light-matter interaction. Coming back to what I said initially, right? I was mentioning industrial metaverse over and over again. You remember the very beginning? I said physics-based. Everything that we do is physics-based. And of course, I talked about ease of use, right? How can we leverage retrieval augmented generation to make it more easy for the end user actually to interact with those models, right? And on the left side, you see a virtual sales assistant, right? A configurator where the end customer is able to leverage natural language to modify that car that you see here, or also in the factory space, how do you leverage retrieval augmented generation, voice interaction with that model to change your view, to better understand what's happening in that factory, to also pull out data, right? To understand, ask questions to your model to see like how is the operational effectiveness of my factory in that space. Now, last but not least, talking a bit about accelerated compute and the technology behind, right? I said it at the beginning, NVIDIA is all around accelerated compute. How can we bring computing to the very next level? How can we speed up computing behind? How do we make sure that what you saw before is actually something that happens in real time, right? You don't want to do that and wait for 2 hours until the rendering is complete. You want to go through that scene in real time. You want to change your angles, how you look at that model in real time. And that's exactly where accelerated compute is super important. And of course, the partnership between AWS and NVIDIA, very important for us to bring the latest technology, both from AWS as well as NVIDIA, to the market. NVIDIA GPUs, powered by AWS, helping our customer to really accelerate training of the AI models I was talking about, helping accelerate the simulations, those physics-based simulations and visualizations via the cloud. And of course, AWS is able to scale that, right? To scale that out in a sustainable, in a cost-efficient and cost-effective way. Now, of course, we're talking about a new paradigm, I would say, in terms of computing. So, accelerated compute, this is going to be the future, right? We're talking about what we call DGX. This is the infrastructure to really train your AI models. This is the infrastructure to generate assets, to generate training data to further enhance your AI models again, to retrain them if you don't have enough training data from the actual real world. And that happens over and over again, right? There are so many use cases out there where our customers tell us like, hey, yes, I want to use computer vision here, but I don't have enough training data. Here you go. You can train that. You can generate that data to actually then go in that circle and optimize your models. Now, of course, for Omniverse, the industrial Metaverse platform, well, you need a different kind of server, right? This is then really in terms of how do we visualize in real time, do that rendering, that photorealistic physics-based rendering in real time. And last but not least, the question, of course, is also how do I now bring that into my actual assets, right? And this is where we provide the AGX platform, which is actually the platform that you can directly integrate into your assets, into your robotics to help speed up the actual inferencing on site. Now, how does it look like? Let's take a look at that video here. What you see here is basically a logistics environment, right? And what we demonstrate is the combination now of that virtual environment with Omniverse. You see synthetic data being created, generated to actually set up this scene. Different assets simulated in that environment. And of course, with different views, combining it now with computer vision, right? You want to understand what's actually going on in my factory. So it's not only like just the visualization and you can simulate and you can optimize, but it's about understanding what's right now in this moment going on in that logistics environment, right? What you see here is being based on co-opt, a optimization routing model, and now actually an incident happened. Damn it, what do we do now? Well, the good thing is we have cameras installed. We're using computer vision to understand, like, look, here, something happened. We can feed that back, and you see the AMR, the AGV, now being rerouted automatically, right? So combining all those different assets, combining that with computer vision, combining that with routing optimization, this is what's the core of how we bring together all those different data sources, right? And bring that together via NVIDIA Omniverse Cloud on the industrial Metaverse side, but also combining that with the DGX Cloud, which is then the AI side of things, helping you with computer vision, routing optimization, like I said before. And so this is really what we think about in terms of industrial Metaverse. How do we leverage all those different technologies, and how can we bring that together? So Omniverse, very high-level overview here, right? It's really a tool consisting out of APIs, various tool sets, software development kits that brings that full power of what you can do with AI, with the visualization of those different tools to the developers, right? And we have many partners. I mentioned Siemens before. Siemens using Teamcenter X, for example, as the first example, tapping into or leveraging our Omniverse APIs to bring new experience to the customer, right? To really bring this photorealistic, physics-based environment to their customer, help them leverage AI during their development phase, right? And of course, like I said before, it's not only about accelerated compute, it's also about ray tracing. A couple of examples here. The importance of ray tracing is really this photorealistic visualization, physics-based. I'm repeating that over and over again, right? You don't want just to have a visualization that is something. You want to have it as physically accurate as possible. And this is what we're bringing together with Omniverse and all the related technologies around that. I think that one we can skip. I mentioned the partnership between Siemens and NVIDIA, and so they are the first one to actually use the Omniverse API to really bring that full extent of the industrial Metaverse to their customers, helping them be more cost efficient and more cost effective. This is just a brief overview on how that looks like. The demo you can see actually at our booth. I'm not sure if we actually are able to hear the sound now on the next slide. That would be the closing video, sort of my presentation here. Let's try that out if there is some sound. I guess not. So, doesn't make much sense to run that video. I don't want to talk over the CEO of Siemens, obviously. We can give it one more shot if we can make that happen. Doesn't seem to work. The Hannover is still catching up, right? So what you see here is basically starting with Teamcenter on the one side, how to develop all those assets, right? And then, of course, leverage all the different data sources again, bringing that together, overview on how Siemens is combining the Omniverse API with their tools, right? And then, of course, extending all the different data sets, massive engineering data sets, right? In that case, HD Hyundai, talking about 7.5 million parts, which make up this ship here, right? Combining this massive engineering data set with all the different tool sets, bringing full fidelity visualization to their customer. That really helps them to better understand across all the different teams what's actually going on in the different parts of that ship, and how can I become more efficient, how can I become more effective in that regards, how can I keep my cost in where it should be, right? How can I make sure that in 26 months that ship actually is finished the way we plan to have it, right? And again, like based on Omniverse Cloud APIs, this is bringing the latest technology to the developers to develop and deploy their application on top of that, right? Now, with that, thank you for your attention. If you want to have a look at that in real life, right, please feel free to join us here at the AWS booth. We have exactly that demo running there. With that, thank you for your attention. Apologies for the slight issue with the sound, and looking forward to catch up with you and discuss. Thank you.